Hello, today we're going to be looking at an activity from chapter 1 called Matter and Its Properties. It might also be listed as chemical versus physical properties. Before we begin, please make sure you have a couple things. You will need this handout that has been uploaded to Google Classroom. Also, you will need 3 objects that hopefully you will have something similar, if not exactly like these in your home. You will need a cotton ball, a crayon, and a penny. So please make sure that you have those at your disposal as well. Please take a moment and read through the front page. What we did in class the day we did this, I gave everyone a couple minutes to read through the front page to familiarize yourself with the definitions and the procedure that we are getting ready to do. So pause the video at this time, read the front page. When you are done reading the front page, we looked at a couple things together. So what we are going to be doing in this activity is hopefully clarifying some of our key terms from chapter 1. We're going to explain the difference between chemical and physical properties. We're going to also explain the difference between chemical and physical changes, which will be very much related. Then we will also look at the difference between extensive and intensive properties. That's the one that most students struggle with a little bit or are not as familiar with as the other. So, to get us started with our 3 objects, cotton, penny, and a crayon, we simply get started by making some observations. What observations we make aren't going to be super important, as we'll see. So, we got our 5 senses that we can use. Remember, we do not use taste in a chemistry lab, but we have 5 senses, or left with 4 senses to make our observations. So for instance, I can think about this cotton ball here, and I can observe that cotton is light and fluffy. That's actually 2 different observations, that cotton is light and that cotton is fluffy. So if I examine those 2 observations, if I think about the observation that cotton is light, if I look and I want to define this as either a physical or a chemical property. If I look at my definition of a chemical property, it's that it relates to a substance's ability to undergo changes that transform them into different substances. So when I say cotton is light, that has nothing to do with cotton transforming into a different substance. So it's not a chemical property, it is a physical property, which that definition reads, a characteristic that can be observed or measured without changing the identity of the substance. So when I say cotton is light, I can say that and measure that without changing the identity of this cotton ball. All right, so we now know it's a physical property. Let's look at our second one. Our second observation was that cotton is fluffy. All right, so again, if I observe that about my cotton ball here, I can say cotton is fluffy. We'd all agree with that. Again, our observations we should be in agreement with. We might not all observe the same thing, but we should be in agreement when we notice them. So would that be a chemical or a physical property? Think to yourself first. You hopefully would agree that that is a physical property. Again, I can observe that cotton is fluffy without changing the identity or transforming it into a different substance. It's a physical property because I can observe it without changing the identity. So light and fluffy are both physical properties. Now, next thing we want to look at is it intensive or extensive property? So let's go back to the fact that cotton is light. Now, if I think about cotton as light, I look at the definition of extensive. Extensive properties depend on the amount of matter present. So when I say cotton is light, here's a way to think about that. Is that true whether I have 1 cotton ball or a whole bag of cotton balls or a truckload of cotton balls? Is it is the saying, cotton is light? Does it depend on how much I have? And you hopefully can recognize that since I'm talking about the mass, essentially, or the weight of the cotton, it does depend on how much I have. One cotton ball is light. A truckload of cotton balls would not be light. And so that is an extensive property. It depends on the amount of matter that is present. All right, our second property was that cotton is fluffy. Again, if we view it as that on that same lens, this cotton is fluffy. I want to see, okay, is it still true if I have a bag of cotton balls or if I have a truckload of cotton balls? And that would be true in all cases, regardless of how much I have. This cotton's fluffy, this cotton's fluffy. And so that is an example of an intensive property because it does not depend on the amount of matter that is present. Okay? All right. So that's a couple of examples of properties that anybody could come along and make on a cotton ball. All right, at this point, what we did in class and what I would like for you to do as well, if you flip to the back side of this paper, you'll notice the data table up top. There's a spot for all three of your objects, cotton, crayon, and a penny. The left-hand column is intensive properties. The right-hand column is extensive properties. And you can see where I have fluffy and light there. Fluffy was an intensive property, so I have it in the left-hand column, and it was a physical property, so I have a P in parentheses. Cotton is light. That was an extensive property, so that is in the right-hand column, and there's a P in parentheses because that was a physical property. What I asked everyone and will ask you to do is get at least one observation in each of the 6 boxes. Again, if you have trouble with observations, again, remember your 4 available senses. If you have trouble with observations, you can literally go ask a younger sibling or something, because again, we literally just said cotton is fluffy. That's a perfectly adequate observation. We then just want to identify, is it extensive or intensive? And then secondly, is it chemical or physical? What we did in class, I had everyone get at least one observation or one more thing in each box, and then we shared with table partners, so eventually we had at least 2 things in each box because your table partner, a table partner should have hopefully made different observations. For you guys that missed, I will ask that you have at least 2 more things in each box. This will take you a few minutes to do that, so go ahead and pause the video until you have at least 2 observations in each of the 6 boxes. Once you have all of your observations, you can unpause the video and let's discuss a little bit what you have. Now, this is one part that is hard to replicate via video because there are literally dozens, if not hundreds, of different observations that you could have made. And there is no way for me to predict with any accuracy what predictions you made. So I'm not, unfortunately, going to be able to look at your specific observations here. I will when you turn in this activity, but I can't predict what students observe. What I do want to go down and look at is there where it says procedure part 2. Here's something I can predict, and that's looking at the physical and chemical. If you go back and look at your observations, almost all students end up with mostly, if not all, physical observations or physical properties, excuse me. It is much tougher to come up with chemical properties. And so that is a very important thing that I will address because you may or may not have thought of some chemical properties. Now, go back to physical properties or intensive and extensive. So for our crayon, again, a way to think about this, whether or not it's intensive or extensive, is, okay, does it matter whether I have this crayon or this crayon? Um, if I said this crayon's long, well, that's extensive because this one's short. Again, that's just an example. If I said this crayon's blue, well, that'd be intensive because they're both blue. If I say it feels waxy, well, that's true for both. That would be intensive. Those are some examples that I know I've heard just this last hour, so they're fresh in my mind. For pennies, whether they're intensive or extensive, how I can think about this is, all right, does it matter whether I have one penny or a pile of pennies? If that helps, by the way, if that helps you think about some observations, you might pause the video and jot down a couple more things. But if I have these, you might have mentioned that the color again, that it's brownish, that would be intensive. If you mentioned the thickness, one penny is very, very thin. Stack of pennies would be very thick. And so that would be an extensive property. Those were the most common ones. Oh, the width, that was one I heard this class. The width is the same, regardless of whether I'm talking about one penny or a bunch of pennies. And so the width would be intensive. Again, many different, smooth, flat. Again, there are literally dozens of observations that you could have made. All right, now again, once we discussed a few of those things in class, most of the ones that students volunteered turned out to be physical properties. In an entire day's worth of classes, I don't think I actually got anybody that volunteered a chemical property until I prompted them. So let's look at that next. And I actually want you to go back and think about something that could be a chemical property. And if we look at our definition for that, a chemical property relates to a substance's ability to undergo changes that transform it into a different substance. And there were two common ones that I did hear in most classes once I prompted students. So I want to ask that you pause the video again if you haven't already thought about them and think for a couple minutes on, okay, what's a chemical change or a chemical property that I could describe about cotton? And on the pennies, I'll give you a hint here. There's something that is observable on pennies, that is observable on some pennies, I should say, that is evidence of a chemical reaction that has happened. It's not always obvious. It's usually not super obvious, as a matter of fact. But let me see if I can find one. There's no way you'll be able to see this on our camera, but I'll dream a little. Maybe just a hair, actually. If you look up there by the tip of my fingers, there's just a little green speck that you can just barely see. That green speck is evidence of a chemical reaction. Metals react with the oxygen in the air. They oxidize, and so that is evidence of a chemical reaction or a chemical change, and therefore that is a chemical property. Again, that we'll learn about this in much, much more detail later in the school year. But metals, when they are outside with the air, most metals react with the oxygen out of the air. The one that students are most familiar with is iron. Iron reacts with oxygen in the air to create the reddish chemical that is commonly known as rust. The technical chemical name we'll learn is actually called iron oxide. Copper does something very similar. When it rusts or oxidizes, it turns green. If you think about the Statue of Liberty in New York City, for instance, it has turned green because it was originally made of copper. That green substance is a new chemical called copper oxide. Okay, the other common or somewhat common chemical property that some students mentioned was that cotton is flammable or can burn or is combustible. Three different ways of kind of saying the same thing. That is another chemical property because if something burns, it's going to obviously change the identity of this substance. It would no longer be a cotton ball there. All right, now we're going to demonstrate. We then demonstrated a few chemistry or chemical versus physical changes. Hopefully these will show up relatively well on our video here. So first illustration before we get to the very bottom of the page is I just have a very simple matchstick, and if I do this, think to yourself, is that a chemical or is that a physical change? And you hopefully would agree that that is a physical change. Chemically, I did not change anything there. I physically still have the same thing. I just have it in two pieces. Next thing we did, see how this looks on video. Actually shows up decently well with my shirt in the background. But if we think about if we actually strike a match, is that a chemical or physical change? You hopefully would all agree that that is a physical change. I'm sorry, I just said the wrong thing. If I remember, I'll delete that from the video, but I am likely to forget, so scratch that. That is a chemical change. Hopefully you caught that before I did. Because I changed the identity of the substance. I no longer have the chemicals on the match tip that I once did. There are sulfur and some chlorates. The red strip on a matchbox has some phosphorus. There's actually a lot of chemicals involved in a match tip that I won't get into right this second. But I can see here visibly they're clearly different tips now. I would not be able to strike this on my matchbox and expect it to light again. All right, so that was a chemical change. Now what we'll do, so if you look on your handout, I'm going to hold a match up to each of your three objects. I do not necessarily recommend that you do this part at home without at least someone else supervising your work in case something happens. And so do not replicate this part. But if I hold up a match to my crayon for a few seconds, and identify on your handout whether you think this is a chemical change, physical change, or no change. And hopefully you can see that it drips. There it fell. So circle whether you think it is chemical, physical, or no change. And then I will do the same thing with the penny. And if I can find where I put my penny, there it is. And again, I want you to indicate on your handout whether you think this is a chemical change, physical change, or no change. And our third thing is a cotton ball. And like before, I hold the match up to it for a few seconds and indicate whether that is a chemical change, physical change, or no change. Okay, so those are crayon, penny, and cotton. Now let's discuss each one of those to see what conclusion you came up with. Most students think this third one, the cotton ball, is actually the simplest of the three. You hopefully agreed that this was a chemical change, um, not physical change, and certainly not no change. Now, the reason why most students think this one is the easiest, frankly, is pretty straightforward, and it's the answer to this question is, do I still have a cotton ball here? The answer clearly is no. This identity is clearly different than this identity. Not just appearances, but the actual chemical involved. I no longer have cotton. I now have, after a combustion reaction, perfect combustion, I would have nothing left. But I have a little bit of ashes, a little bit of moisture, that's a little bit of water vapor, and some carbon dioxide gas. But that is a chemical change. The penny, when I heat it up near the match, most students agree that there is no most students agree that there is no chemical change here. But I usually have a lot of disagreement on whether this is a physical change or no change. Many students put no change here, but I want you to ask yourself, would you grab that penny right now if you were actually here? You most definitely should answer no to that, because it's not a surprise if we think about it that this penny is extremely hot now, because metal conducts heat and electricity very easily. Because it heats up and heats up very quickly, actually it doesn't have to heat up quickly to do this, but because it heats up, that is a physical change. Now the important takeaway here is that we do not always have to see the change. Remember, we have all five senses of observation. This one, we could feel it if we touched it, but we don't actually have to see the change or even observe the change in order for the change to happen. Okay? And then the first thing we looked at was a crayon. Again, most students on this one agree that there is a change of some sort. I rarely have anybody that would put no change. So the real question is whether it's a physical change or a chemical change. Forgot to actually look on the screen to see how well you can see it, but yeah, you can see the drips there. So the question is whether it is chemical or physical. Now, to truly answer that, let's go back to this cotton ball. Because if we understand that this one was easy, and the reason it was easy is because, okay, do we have a cotton ball here still? Definitely not. Therefore, a chemical change from this to this. If we ask that same question, do I still have a crayon here? The answer is yes. It's liquefied, but I still have crayon. And so I undergo a physical state change, but I do not undergo a chemical change. A good example of this, and this is a very important misconception to clear up, one of the main reasons why I do this activity. If I think about state changes, in our class we will prefer, or it's actually better to call them physical state changes. Because if it undergoes a state change, that is physical only. It is not a chemical change. As an example that you're all familiar with and have all seen, if you think about water, and the chemical formula for water is H2O. If you freeze water, what's the chemical formula at that point? Well, you hopefully recognize that ice is just simply solid water. The chemical formula is still H2O. Similarly, if you boil water on a stovetop or over a flame or any other way, if you boil water, you get steam. Well, the chemical formula for steam is still H2O. So the chemical does not change, and so that is an example of a physical change, not a chemical change. So change in state, going from solid to a liquid, liquid to a gas. Again, we call those things melting, freezing, boiling, and condensation are the four most common terms, but all of those are examples of physical changes. Okay, in class, this was one where we essentially did the entire activity together. I had students turn this in class. For those of you that were absent or online, please email me this directly. And thank you for your time, and that concludes this activity. Thank you.